is Lisa, and I am the author of the blogs on Better Than Sober. And in this video, I'd like to talk a little about what I know about the brain and the science behind addiction, and why it is that traditional recovery programs, the 12 Steps and Alcoholics Anonymous, has worked for the people that it has worked for. And in order to explain this, we need to look at addiction and where that happens in the brain. So I'm going to be talking about our brains today. And first of all, I need to say that the addiction comes from our older brain. And so when we talk about our brains, what we know is that the human brain developed from the bottom up. And what I mean by that is that we first started with a reptilian brain back millions of years ago, and then we evolved a mammal brain, or the emotional brain. That's the older brain, and that's the brain I'm going to talk about mostly today, because that's where addiction happens. And so if you imagine that my fist here is our first brain, there is a structure inside this brain, deep inside the brain, that is constantly scanning the environment, constantly scanning your environment for threats to your survival, or things that are necessary for survival. And a craving for alcohol, at its very least, when it's the least activated, is sort of like a mild stress response. When it's the most activated and a full-blown, desire or craving urge to drink right in the moment, that is like a really strong stress response. And so in order to understand that, we have to look at where the stress response comes from, and it comes from this part of the brain as well, the older brain. And the chemicals that are involved in stress response and craving is mostly dopamine, but also cortisol and adrenaline, among others, and other structures in the brain are also involved here. But so this is our first brain, and what lives in this brain primarily is our survival instincts. And so instincts, right? That is, instincts are things we don't have control over. So this is our unconscious brain. It just sort of takes over when we need it very, very quickly and just reacts. Okay, and so this part of the brain is all about the present moment, and that's when you have a craving, right? It's all about the now, the next 30 seconds. That was this part of this older brain was responsible for keeping us alive for the next 30 seconds, and that's all. That was its job. And in order to understand how addiction works, keep in mind that when this brain was evolving over hundreds of thousands of years and hundreds of thousands of years ago, our existence was very different than it is now. We had very, very few resources, very little variety in our daily lives, very meager existence, really, okay? And so this part of the brain, the older brain, developed a very simple assessment system for determining what in our environment was essential or detrimental to our survival. And what it looked at, or how it determined this, was based on our five senses and how something smelled or looked or tasted or felt, or what it sounded like, and that's how the older part of the brain decided that this is necessary for survival or detrimental to survival. And so the example that I'm going to give you is that imagine a foraging woman runs across a food source, and it looks okay, and it smells good, smells okay, and so she tastes it, and it tastes fine. And so she eats a little, and it fills her up, and so she doesn't gag, she doesn't die. And so this part of the brain codes that new food source as good or necessary for survival, okay? Conversely, if she runs across something that looks gross, smells terrible, and tastes disgusting, makes her gag, she's not going to eat that. And this part of the brain is going to code that as no, move away from that, don't go there, right? and the experience or the thing is, the more likely this part of the brain will then, after a time or two, the next time it sees the same food source in her environment, it's going to go, oh, we remember that. That was good. Go to that. Get that. And so it's sort of, habit. And then eventually, if it's very good, imagine that it was meat for the first time. And imagine, the brain is going, oh, this is fills you up. It's high calories, it's protein. This is really, really good. So this part of the brain is going to give that meat, fresh meat, a really high value or really high assessment, okay? And it may even make that such a high assessment that that would become the object of its desire. And it essentially becomes, it's called that in the neuroscience world, and that would essentially become obsessed with meat. And then eventually, what's going to happen is man is going to start trapping and hunting meat for food, and that's really going to go a long way for helping us survive as a species, right? Now, fast forward a few hundred years, and what's happened with this brain is that in relation or in response to our environment, we have developed a newer modern brain, and that's what this little pink cap represents. So this is our prefrontal cortex. This, now again, even though I say it's newer and modern, it is still hundreds of thousands of years old. And the way evolution works is it doesn't replace the brain that's already there. It's still there, and it's still functioning the way it always has. It's still scanning the environment, looking for threats or looking for things that are detrimental or essential for survival. But evolution has just added on to it and made it even better, okay? So now we have our prefrontal cortex, and hopefully these two brains, parts of your brain, work really well together, because if they do, what you'll get is this is our prefrontal cortex, and this part of the brain, this newer brain, gave us fire and the internet and everything in between. Okay, this is your CEO of your body. This is the overseer, and this brain brought us into the present day. The prefrontal cortex is so awesome that it can influence and control and regulate the older brain, so that when we don't need it, it can kind of calm it down, okay, and sort of take over. The prefrontal cortex is not about reaction like the instinctual older brain is. The prefrontal cortex is about response. It's a little slower on the draw, but it does kind of think about it. It's logical, and it has past awareness. It can remember, and it has future awareness. So it can look ahead and create. That's how we have invented things, okay? Something didn't exist. The internet didn't exist, and now it does. So how did we do that? We did that with the prefrontal cortex. Okay, so if both of these are working really, really well together, then that's the way it should work. And let me give you an example from modern day. And that is, let's say that our foraging woman has now become a 21st century working girl, okay? And she's on her way to work, and she walks past the bakery. And the older brain goes, oh, donut, smell donuts, go get donuts. And it immediately releases dopamine. Remember, I talked about dopamine. That's one of the chemicals. That dopamine comes from the Latin word, which means motivus, which is to motivate. And motivate is literally to propel, to get you up, to make you move and go towards something. And isn't that what an urge to drink really sometimes feels like? That's the restlessness that we get from addiction. Okay? But so what the prefrontal cortex is able to do, though, is she may think about the donut, because she's probably hungry, and she's like, ooh, that would be good. But her prefrontal cortex goes, wait a minute. Remember, we have that wedding in 2 months. We're losing 20 pounds. We're watching our sugar intake. And so the prefrontal cortex will actually send a chemical down to the older brain that's sending the craving. It'll send something down to say, pipe down. Nope, we're not going there. Not this morning. Remember, we're watching our sugar intake. We're watching our diet, whatever. It's able to actually switch it off. And so, even though she thinks about it, she's able to just kind of breeze past the bakery and go get a healthy smoothie instead. Okay, so that's the way it's supposed to work. And if both parts of the brain are communicating well with each other, then that happens, and then the older brain switches off and goes about scanning for, threats and so on. But um, and that's the way it works for normal drinkers. If you think about this, say a normal drinker's at work on Friday, at work at 5 o'clock, and the older brain that where the craving comes from says, "Ooh, it's 5 o'clock. Let's go have some drinks," and the prefrontal cortex is going to go, "Ooh, wait a minute. No, we're not doing that tonight. Remember, last weekend we did that and we drank too much, and that did not work out well." It has past awareness, and it remembers, so it can bring that information, that memory, and those emotions of feeling like crap or saying something stupid or whatever that person did. It can bring that to bear on that present moment where the urge is coming from, or it can look ahead and go, "No, we have the 5K tomorrow morning. We're not going to drink tonight because we need to be ready for that race up at 8 o'clock, whatever." And so again, it can switch off the older brain, and that's what you want to happen. Okay, so why doesn't that happen for some of us? It didn't happen for me, and for about 30% of the population, if you're like me. Why can't my prefrontal cortex get that older brain under control? And so what's going on there? And in order to talk about that, I'm gonna do a second video. And so I hope this was helpful. And if you come back next week at the same time, I'll release a second video that explains more about this. In the meantime, check out my website, betterthansober.com, and thank you for watching.